Okay, so just as we did with rational expressions in chapter 6, right, we dealt with rational expressions, rational functions, and rational equations. We're going to do the same thing with radicals, right? So in the first three sections of chapter 7, right, 7.1 to 7.3, we dealt with the radical expressions, and now in 7.4, we're going to deal with the radical functions. And then in 7.5, we'll move to radical equations. Okay, so we're going to mainly focus on the graphs, right, on the functions, only square root and cube root functions. Okay, so the radical functions that we'll be dealing with are just the square root and the cube root functions, and then you can see the graphs of them below, right? Right here are the graphs. Okay, so this one on the left here, this would be the graph of y equals the square root of x, or f of x equals the square root of x, and you can see that it starts out over here, right, at this point 0, 0, and then it continues up and to the right. Okay, and then this one on the right here, this is your graph of y equals the cube root of x, and this one actually goes all the way to the left and all the way to the right. Okay, so that's the first thing to note here. What are the domain and range for these functions? Okay, so the square root graph, right, because if you remember from our first few sections with the expressions, we can only take the square root of a positive number or 0. So the domain of the square root function is actually going to be all the real numbers that start at 0 and then go to infinity, right? And again, you can just see this from the graph, because remember what we said when you do domain and range from a graph. Domain is how far left to right the graph goes. So where does this go left to right? It starts out here at 0 and then goes all the way to the right. So the domain is 0 to infinity. And then for the range, you're looking bottom to top, right? So the bottom is 0, and the top, it's not really obvious here, but this thing is going to continue to go up as it goes to the right. So this is actually going to go all the way from 0, right, to infinity. Okay, and if you remember, infinity always gets a parenthesis because it's not a real number, so it can't be included in an interval. Right? Bracket means the number is included, parenthesis means the number is not included, but of course infinity is not a real number. Okay, so that's your domain and range for the square root graph. And the domain and the range for the cube root graph, I mean, you can see here that the cube root graph is actually going all the way to the left, all the way to the right, and it's going all the way down and all the way up. So actually, for the cube root graph, the domain and range are both going to be negative infinity to positive infinity. And remember again from the first three sections with the radical expressions, you can take the cube root of a negative number, right? You can take the cube root of any number, whereas you can only take the square root of a positive number or 0, right? The square root of a negative number did not exist. So hence the difference in the domains of the square root and the cube root functions. Okay? So those are just what the graphs look like. And then this is where I note the fact that they are increasing functions, right? In other words, they're going up. As you look left to right, what's happening? They're going up, but they are going up actually very slowly. So, and then I give you a few examples here, right? So when you're dealing with the square root graph, y only increases by 1 as x goes from one perfect square to the next. Right? When you're dealing with the cube root graph, y only increases by 1 as x goes from one perfect cube to the next. Okay, so probably the better way to look at this, to think about this, is in a table form, right? So if you're dealing with y equals the square root of x, and you had a table for x and y, right? So the square root of 0 is 0, the square root of 1 is 1. So that's fine and dandy. But now y is not going to reach 2 until x is 4, right? Y is not going to reach 3 until x is 9, and y is not going to reach 4 until x is 16. and then it's not going to reach 5 until x is 25, and so on and so forth. So yes, y is going to keep increasing, but it's increasing actually very, very slowly, right? Because you see how the change in the x here keeps getting larger and larger. And then the same thing is going to occur with the cube root graph. If you had the graph of y equals the cube root of x, again, 0, 0 works, 1, 1 works, but then y isn't going to be 2 until x is 8, and y isn't going to be 3 until x is 27, right? Because the cube root of 27 is 3, and then y isn't going to be 4 until x is 64, and y isn't going to be 5 until x is 125. So yes, y continues to increase, but it increases very, very slowly, right? It takes a long time for y to get to 5, right? It doesn't get to 5 until x is 125. So yeah, it's going to keep increasing, but it's just going to increase very, very, very slowly. And you can see this fact from a table, right? If I go to my calculator and I put y1 is the square root of x and y2 is the cube root of x, and then go to my table, I'll be able to see that, yes, the square root and the cube root graph, right, they're both going to continue to increase. It's just that they're going to increase at a slower and slower rate, right? Again, you can see here that when x reaches 36, the square root of x finally gets to 6, and the cube root of x is still, just a little bit more than 3. Okay, so they're going to keep going up and up and up, but they're just going to go up and up and up very, 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 very slowly. Okay, so that's the idea of looking at it from a table standpoint. I'm sorry, yeah, from a table standpoint. Okay, and then again, I mean, domain of a square root function, fairly straightforward, right? What do you need? What do you need? You need to ensure that this thing, right, the radicand, the expression that's underneath the square root sign, is greater than or equal to 0. Okay, so whenever you want to find the domain of any square root function, just take the radicand, right, which is in this case 2x minus 9, and say, all right, well, this thing is underneath the square root sign, so it's got to be bigger than or equal to 0. And then just solve this inequality, right? So if 2x minus 9 is greater than or equal to 0, you knew 2x is greater than or equal to 9, and therefore x is greater than or equal to 9 over 2, right? And then, again, what does this mean in interval notation? It means everything from 9 over 2 on to infinity. So the domain there would be from 9 halves to infinity. Okay? And that negative sign out front didn't impact the domain, right? It impacts the range, right, as you'll see if we do a graph of this in a second, but it won't impact the domain, right? The domain is just going to be take the radicand, right, the thing under the square root sign, and set it greater than or equal to 0. So the same thing with b here, g of x equals the square root of 6 minus 3x. I need that radicand, 6 minus 3x, to be greater than or equal to 0. Right? And the only difference here is that I subtract 6, but then I have to divide by a negative. So remember what happens when you divide by a negative. This greater than or equal to symbol is going to become less than or equal to, and negative 6 over negative 3 is actually 2. So this is saying that the domain is everything less than or equal to 2, which means that the domain goes from negative infinity up to 2. Okay? So that would be your domain of those two radical functions. Okay? And then again, I can enter these into my calculator and just take a look, if not at the graph, at least at the table, right? Negative square root of 2x minus 9. And I can see if I go to my table, well, I don't want to start back there where I had gone before. Let's start at 0. But you can see, alright, at 0 I get an error message. At all these negatives I'm getting an error message, meaning it's not defined there. So it's not defined in my table here until, x got to 5. But this is only going by ones, so if I wanted to see the actual point where it started, I could change my table to go by halves. and then I'd be able to see that, in fact, it is defined at 4.5, right? That's where y equals 0, because that ends up being the square root of 0, which equals 0. So it's defined everywhere from 4.5, or 9 halves, to infinity. Okay? And I mean, you can do a little graph of this and see what it looks like, right? If I go to the standard window, I should be able to see it. Okay? And there it is. So in this case, it's actually going down and to the right. Okay? That's not the ideal window to use, obviously, but you at least get the idea of what it looks like. Okay? And then the other one was 6 minus 3x, right? The square root of 6 minus 3x. So let's change this to 6 minus 3x, right? The square root of 6 minus 3x. And if I go to my table here, I can see that, all right, it's actually undefined at these positive numbers here. However, once I reach 2, it was defined, right? It was defined at 2, and then everywhere to the left of this, it's also defined. So that's where my domain of negative infinity to 2 came from, right? It's defined for everything that's less than or equal to 2, right? Because at 2 it's 0, because the square root of 0 would be 0. And then if I do a graph of this, you can see that it's defined from negative infinity up to positive 2, right? And it ends at this point right here, 2, 0. All right, so that would be your graph of the square root of 6 minus 3x. And then I have a little note at the bottom here about the domain of a cube root function, right? Being that you can take the cube root of any real number, be it positive, negative, or 0, the domain of any cube root function is always going to be just negative infinity to infinity, right? All real numbers, because you can take the cube root of, right, any, meaning negative infinity to infinity, real number. Okay, so that's why the domain of the cube root function is just going to be negative infinity to infinity. So we just showed you how to find the domain of a square root function, right? You would just take the radicand and ensure that it is greater than or equal to 0. I just kind of wanted to give an idea of what these things look like graphically. Okay, so again, the regular square root function just looks like this, right? Let me just change this to make it look a little darker. There we go. Right? So there's just your basic square root function, right? It starts out at 0, 0, and then it would go up and to the right. Now if I graph, let's say, the square root of x plus 5, that would actually start at negative 5 and then go up and to the right from there. Okay? And if I graphed the square root of x minus 5, that would actually start at positive 5 and go up and to the right from there. Right? And again, you can verify that those would be the correct domains just by setting the radicands greater than or equal to 0. Okay? So then just in general, let's say I had the function the square root of x minus a, right, where a is some value that can be changed. So if a starts out at 0, right, I would just have the square root of x minus 0, which is just the square root of x. Okay? So now if I made this a value positive, what's going to happen? I have like the square root of x minus 1 is shifted 1 unit to the right. If I have the square root of x minus 2, it's shifted 2 to the right. Square root of x minus 3, 3 to the right, so on and so forth. So as I make my a value more and more positive, I'm moving this graph over to the right. And then, what if I made a negative? If a is negative 1, right, I have x minus negative 1, which is really like the square root of x plus 1. I've actually moved it now to the left. So if I have the square root of x minus negative 2, again, which is the square root of x plus 2, I've moved it 2 to the left. And then so on and so forth. Negative 4, so now it's 4 to the left. And negative 5, 5 to the left, so on and so forth. So all my a value here is doing is shifting my basic square root graph to the right or to the left, right, depending on whether it is positive or negative. But again, the thing that you have to keep in mind there is that that graph is the square root of x minus a. So when a is positive, it's really x minus a positive number, right? When a is negative, it's really x plus a number. Okay, so you got to be careful there. All right, so that was just your x square root of x minus a, and then you could also look at the graph of the square root of negative x, and what happens there? That actually goes in the opposite direction, right? Instead of starting at 0 and going up and to the right, it actually goes from negative infinity, right, from all the way to the left, up to 0. So that's actually, if you compare that to the graph of y equals the square root of x, look how they compare there. They're actually reflections of each other, right, in the y-axis. So what ends up happening is, if you flip the red graph over the y-axis, you end up with the blue graph, okay, which is the square root of negative x, right? And then you can again look at various values of this kind of function, right? If I change the square root of negative x to the square root of 5 minus x, so I inserted a 5 before the negative x, that actually moved it over 5 spaces to the right. And then just in general again, if I have the square root of a minus x, and I want to change the value of a to be various numbers, I can move a and make it positive, I'm moving to the right, or I can make a negative and then I'm moving to the left, right? So the idea here is all of those graphs were very similar. It was just a matter of them being shifted to the right or to the left by changing my value of a, right?